The European Green Deal calls for a 90% reduction in greenhouse gas emissions from transport, and thus by 2050 rail freight traffic will need to be doubled. Digitalization will become an indispensable driver for the modernization, which is why the FP5 TRANS4M-R consortium in 2022 got granted 95 million euros to bring forth a solution for digital freight train operations enabled by digital automatic couplers. The solution enables digital functions for train composition, automated uncoupling of wagons, automated brake tests, train integrity, and train length determination, which will increase capacity and efficiency in the rail system. The more than 70 project partners have together agreed on technical and functional requirements suitable for a common European railway. To ensure a safe and reliable solution, the innovations need extensive testing before being ready for installation on the 500,000 wagons used in Europe. My name is Anna Björkman, responsible for coordination of the tests within the project. And in this video, I'll give you a deep dive into the test activities that have been made around Europe at the locations shown on the map during the first 2 years of the projects. Activities starts in the test rigs of the suppliers, and when the solutions are mature enough, we proceed in the train test lab with the tests on wagons and test track in a closed and safe environment. Finally, tests can be conducted in the demonstrator trains on public tracks. In this film, we want to provide an insight of the activities in the train test lab and demonstrator trains, starting by looking into our train test lab in Berlin. The train test lab consists of several locations where Berlin-Spandau is our main hub. Here, tests focusing on installation, interoperability, e-coupler assessment and reference test system were conducted in this first phase. Most wagons have an UIC installation space under the wagon that allows standardized installation. The first essential test was to confirm this application. We investigated if there was a uniform way to install couplers from different manufacturers. Results showed that the ducts from different suppliers could be installed on the freight wagons with minor modifications on the wagons and similar tools, which could be further streamlined for a future migration phase. Some wagons need additional attention as they have special undercarriages to support their purpose. The pocket wagon T3000, for example, has limited space for the draft gear, which makes installation more complicated. One big goal of FP5 TRANS4M-R is to have reliable, interoperable solutions. As a first step, mechanical compatibility between different suppliers was tested with coupling and uncoupling tests. Coupling operations were tested with speeds up to 12 km per hour, which gave us important results for the upcoming validation test. The uncoupling tests showed that disconnections with the manual uncoupling device was possible and gave us input for further improvements. To ensure higher reliability of interoperable coupling and uncoupling operations, further tests will be made. This manual uncoupling will be the backup to the remote uncoupling, but needs to be in place to ensure resilience. Moving on to the e-coupler, the component enabling data and energy transfer between wagons and thus digitalized train functions. Operational experts selected 2 concepts from Voigt and Knorr-Bremse to undergo a test campaign to decide the e-coupler concept for further development. The e-coupler assessment included tests focusing on installation, coupling with various speeds, curves, loads, and impacts. The coupling operation is made at higher speed, which creates higher forces with bigger risks of damage. To provide data on the impact, measurement systems and cameras are installed to document any damages that may occur in the e-coupler. As a result from the assessment, we have decided on one concept from Voigt for the project. Now we have been concentrating on the coupler. but we also need to investigate the other energy and data features to enable a complete digital freight train. To start early testing of energy and data functionalities, a reference test system has been developed. This system will pilot as a digitalization hub with many functions that the locomotive will later have. The system will be continuously updated with the latest components developed in the project to represent the future architecture of the digital freight train. This means that we can use it to validate interoperability of final solutions by showing that all components from different suppliers are compatible with the reference test system. For future purposes, this system can be used to assure functionality after retrofitting a vehicle. During 2024, it has been possible, thanks to the impressive reference test system, to make both early tests of the function of the remote uncoupling and the initial functions of the automated brake test with a tablet. This is a digital solution for the current manual safety check carried out after every train formation. Going forward to our first demo train, we take a look in Switzerland. Driven by SBB Cargo on public tracks, this demo train has focused on Powerline Plus technology, hump yard operations, and input for the e-coupler assessment. Powerline Plus is the backup communication technology for the data backbone of the full digital freight train operation. It has been recommended to continue the development and testing of Powerline Plus in parallel to the single pair Ethernet solution to assure that all functionalities from at least one is qualified for operations. The focus of the demo train has therefore been to provide insights from real operations operating the Powerline Plus technology, with some selected train functions. In Switzerland, we have also made first tests on solutions to issues with hump shunting. After disconnecting the couplers on the hump, they should be kept separated until they reach the right destination track. To solve this, couplers are put into a locked mode so that it doesn't attach to other couplers while being sorted. For the e-coupler assessment, tests in Switzerland provided results from shunting and running tests, such as measurement regarding micro-interruptions. In Sweden, there are two different demonstration trains, one in the south and one in the north. In the south, we have an intermodal train, which is the first demonstration train in commercial traffic in the European Union. Here, we are observing the behavior of the duck during different seasons over a longer period of time to get a better picture of the life cycle analysis. Looking into this first demo, an intermodal train, preparations and installations were made in Skellefteå, where an educational video was recorded with instructions for the operator and terminal staff. Now, the train is running between Nässjö and Gothenburg Harbour, operated by SHN Cargo. It runs one round per day, 5 times a week, which results in 110,000 kilometers per year. The second demonstrator is a heavy one. We are putting the test to a maximum when Green Cargo uses the couplers on the steel train in the north of Sweden. This heavy load of up to 3,800 tons, along with harsh weather conditions, sets even higher demands on the robustness of the duck. This kind of train requires a stronger brake system, and therefore a solution for double air pipes is necessary. The train will run in the north of Sweden between Borlänge and Luleå with approximately 250,000 kilometers per year. Lessons learned from the two demonstrators will be gathered to provide input for the endurance and reliability of the coupler. This is critical to make sure so that the future solutions endure wear and tear. I hope you've gained insights and inspiration from our overview of ongoing and performed tests within the project. These tests have so far provided us with important results for the ongoing development. Next steps include more focus on validation of the system, evidence for authorization, as well as start of 2 new demonstrator trains in Italy and Austria. These demonstrators will focus on testing the digital functions in real operation. For some final words, we have invited the project manager of FP5 TRANS4M-R.
We need these tests because at the end of the day, it's about authorization. We want to authorize the digital automatic coupler, and therefore we need tests. We need to show that we have a robust product, a reliable product, a safe product, and secure processes. So looking at all of this, of course, we want to go for migration. But before we do so, I am very happy and I'm very much looking forward to introducing the DAC Pioneer trains in Europe.
The Pioneer trains mentioned by Molly will be the next step of the TRANS4M-R project. These trains will run in commercial traffic with a full set of train functions and be the starting point of migration. Until then, follow the progress of FP5 TRANS4M-R, where collaboration and innovation are transforming Europe's rail freight. If you have any questions, don't hesitate to reach out.